Madson, and I'm Tillmans.
And we also have two other teammates who unfortunately couldn't be here with us today, and they are Poli and Hart. Today we're going to talk to you about our iDesign project, which is an aqueduct system for the village of Bajo Gavilan in Panama. First, we're going to talk about a project overview, and then talk through our community background information. Then we're going to talk about our technical assessment that we are working on, and then finish up with a summary of our project, and then time for questions at the end. So, like I said, we're in the iDesign program, an international senior design program here on campus. And for our project, we're working on a gravity-fed water distribution system, or an aqueduct system, for the village of Bajo Gavilan. This is located in Panama, and we were fortunate enough to go to Panama for 2 weeks to work on our project in the field. And while we were in Bajo Gavilan, we conducted a field assessment where we determined community needs, what they needed from the aqueduct, and the constraints associated with that, as well as did some surveying along the proposed aqueduct route. And then we worked very closely with the local Peace Corps volunteer who is residing in Bajo Gavilan, and her name is Christina Dual. She's in that picture right there. She helped us very much to learn about the community and also with the surveying work. And now that we're here back at school, we're working on our final design report for the aqueduct system. So to give you an idea of where we were in Panama, Bajo Gavilan is the village we were staying at, and that's right here. And it's about 200 miles northwest from Panama City, where we also were at for about a week. Bajo Gavilan is located in the Bocas del Toro region or province of Panama, and that is where a lot of Nobe groups of people are located. So the Nobe Bupe people are an indigenous group to Panama, and they were the people that we were going there to help in the Bajo Gavilan community. Nobe people are usually pretty reserved, and especially in our community, they were very shy. This posed quite a challenge for us. Not only did we have a language barrier, their indigenous language is called Nobe, but they also speak a pretty broken Spanish. And obviously, we didn't have much Spanish in the first place, too. But not only that, language barrier, but the fact that they were really shy and they didn't want to talk to us that much, it was very difficult to learn about the community restraints and the community needs, and that's why we relied so much on our Peace Corps volunteer, Christina. Some demographic information: there was about 124 people in the village, so a pretty small village, but there was 16 households. So they had really large families that would stay in these small houses, and they were very close-knit. There was predominantly more women than males, and then 67% of the population, 67% was under the age of 20. So it was a relatively young community. It was also a relatively new community, as some of the older members had only been there for about 40 to 50 years. Another challenge that we faced when we were in Bajo Gavilan was the weather. We were right in the middle of the rainy season, so it rained almost every day, and it was very hot and humid. This posed quite a challenge when we wanted to go out and do surveying work. We could only work from about 8 in the morning to 2 o'clock in the afternoon, and then it would start raining all day or all night. The house picture on the top, that is where we stayed for about a week in the village. All right, so some history about our village. Bajo Gavilan is located downstream from the Changanola Dam, which was constructed in 2010 by an American electrical generation company. This company is called AES, otherwise known as ICE. That's how the Nobe people pronounce it. So you can see in that picture the dam being constructed, and then right here is another Nobe community, not the one we stayed in, but another one that was upstream of the dam. Unfortunately, this community was flooded when the dam was built, and the Nobe people were displaced. Because of this, AES or ICE made a settlement with the Nobe people that they would build local community buildings. And because of this settlement, Bajo Gavilan got a schoolhouse that was built. That's located right about here. So this schoolhouse brought more people to the community, and also more people moved near the schoolhouse in section 1 of the community. So there's 3 different sections of Bajo Gavilan, and they're split up by this road that runs right through. You might be thinking it's kind of weird to see a paved road in the middle of the Panamanian jungle, but it was built there when
The storage container, or the storage basins that collect the water and can provide varying flow depending on the demand. And then downstream further, this existing aqueduct had a completely unburied pipe. When we designed our aqueduct, we're having the entire system buried, not only to prevent things like horses stepping on it or people stepping on it and breaking the pipe, but also to protect the pipe from UV radiation, and that would weaken the PVC pipe. So as I was saying, the current situation, roughly only the 3rd section has access to fresh water, leaving section 1 and 2 without fresh water. There's currently a project under development by the Peace Corps volunteer Christina to expand the existing aqueduct back over to section 2 of the community, leaving only section 1, which is the section that we're working on providing fresh water for. Currently, sections 1 and 2 use the streams that flow nearby their houses to get their fresh water. And this is a big issue because runoff from where the agriculture is, where their horses and chickens are running into those streams, as well as just their living areas. All the bacteria are running into those streams. And this is how they do it. They'd stick a pipe into the stream and the water would flow through that, and they could collect their water there. So our overall mission of the senior design was to go to Panama and survey a route and find the elevation profile for this aqueduct system, and then to come back here and design a system that we can give back to the Peace Corps volunteer who will then work with the community to install it. So while we were in Panama, we really had 3 technical objectives that we were trying to accomplish before we came back. First was to determine the flow rate of the new mountain spring source, which was different than the existing aqueduct. It was kind of on the opposite side of the mountain. And determine if that flow rate was going to be adequate to provide drinking water for the entire population of section 1. And then 2, to survey that aqueduct. While we were there, we didn't really know the best routes. We really had to work with the local population to find a way around the mountains, through the jungle, up and down the hills to really get there in the best manner possible. And then to 3, test the water quality to make sure that the water from this spring source was better than the sources at the springs that they were drawing their water off from currently. Some of the equipment that we used in the field, some of you guys might not recognize it, but it really wouldn't take any of you more than 30 minutes to learn how to use it, which some of the people in our groups didn't know how to use it. We did learn it while we were down in Panama. For testing the water quality, we used Petri films to test for fecal and E. coli coliforms. And we used a rangefinder and a GPS in most of our surveying. The rangefinder takes a horizontal, a vertical, and an actual distance, so we can measure the change in elevation from our point to point. And then we used our GPS to mark each point that we used along the way. The tape measure and the Abney level were really just there for backup in case one of our electronics didn't work or they stopped working because of the rain. So we always had those in our backpack when we were out doing our survey. And then we used the water bottle and the stopwatch for doing our flow rate measurements of the stream. We used a volume over time method. So while we were surveying, for example, Kevin is here holding the GPS, taking a waypoint measurement. We always took a waypoint where we were measuring from and where we were measuring to. And the distance I was shooting at the target that one of the members not here, Clara, is holding was just a staff with we just cut half of a folder in half and stuck it on a stick. So we could shoot the laser literally right at the target and get to the elevation change from each point. The main challenges while surveying were it rained every day, so it was super slippery, steep, very muddy. It was on a mountain, so there's constant valleys up and down. And then also the really heavy foliation made it difficult to shoot a laser straight at each waypoint that we were going to. For the water flow rate, this is what the spring looked like that was coming out of the mountain. We just built a small weir because it was kind of a large flow rate and the mouth of the bottle was fairly small. So we had a really conservative flow rate. Not all the water was going directly down that. And we just used the bottle and had a couple people measuring time while one of us was collecting the water with the bottle for volume over time method. And then finally, for the water quality testing, we just took a small sample, 1 milliliter sample, directly from the spring source and put it on the Petri foam. And then we didn't have anything to incubate it with, so we just kept it in our pocket and used our body heat to incubate the culture.
So this is the result of our survey. It started from the spring here and to the school at number 8, and overall it was about 1.75 miles long. This is just a general figure that shows the profile that we took and prefaces the next slide. This is a more accurate representation of the elevation profile we measured with the rangefinder. On the y-axis, you have elevation above mean sea level, and on the x-axis, you have the distance from the source in miles. You can get three main things from this figure. One is that it dropped over 600 feet from the spring to the school at the end. As Will mentioned, we took waypoints, and each dot represents one of those, so over 118 waypoints we took. And third, it just shows the hills and declines that we encountered that we're going to have to take into account during our design. As far as our other results, we measured the flow rate at the spring to be about 6.9 gallons per minute, and we calculated the demand for section 1 of the community to be about 2 gallons per minute. This was during the rainy season when we measured the spring, and taking into account other data from Christina in the dry season, we expect that the spring will provide adequate flow to the section of the community, and it will be a long-term solution that they can count on. For water quality, the Petri film test result here is from the source, and it shows 0 E. coli contamination, which was promising, compared to the test result here, which you can see the E. coli coliforms in blue with gas bubbles around them. So that represents significant contamination, and this is taken in section 1 of the community from one of those stream sources that Will showed. So overall, this is the water quality that we hope to provide, and this is the water quality that they're currently consuming. So we took all of the survey data, the flow rate data, and the water quality data back to Michigan Tech and compiled it. And right now we're modeling the system using 2 programs called EPANet and NeatWork. They're both free, but EPANet is more commonly used and recognized. NeatWork is less recognized but favorable in the P-score, just because it simplifies the design and it's easy to use. So we're going to compare the results from those 2 just to see what we get. This is an example output from EPANet. This figure shows the pressure increase from the spring to the school. And figures like this will help us identify system needs, which I'll talk about later. We'll also provide design recommendations as far as how the construction team should encounter stream and ravine crossings, and if they need water treatment at all. And lastly, this semester we'll provide a final submittal, which includes a report, a cost estimate, and a scheduled construction for the community. So we're 6 weeks into the semester, and so far we've identified some system needs or components. Like most gravity-fed water distribution systems, it'll need a spring box which collects the water. And then we'll use PVC pipe to transport that water into storage tanks. We'll also need brake pressure tanks and air release valves. The storage tank stores water when it's not in peak demand. The brake pressure tanks will relieve the pressure that accumulates in the pipes that I showed in the previous slide. Will relieve that pressure to prevent the pipes from breaking. And the air release valves will prevent air blockages that might occur and prevent water from flowing to the community. And lastly, we recommend that all pipes be buried to prevent the issues that Will talked about previously. So this is a picture of the extension aqueduct that's currently being extended from section 2 and section 3. And you can see that they trenched their building and eventually will cover that up. So in summary, we traveled to Bajo Gavilan in August 2014, and we determined the community needs, which was that they needed clean water for section 1 of the community. And then while in Panama, we surveyed the proposed aqueduct route, and right now we're designing and modeling the system, and then later we'll provide a final report, design, and cost estimate to the community. So So as Megan and Will mentioned, we encountered a number of challenges during our experience there, and we couldn't have got through it without help from the community of Bajo Gavilan, Christina Duell, Dr. Watkins, and Mr. Drewer. And lastly, we'd like to thank you for attending the presentation today and hearing what we have to say. So this concludes our presentation. Do you guys have any questions? Yes.
So how did you know about the